Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall discuss the topic of bearings. So in this question, we're told the bearing of B from A is 105 degrees. Find the bearing of A from B. So the bearing of B from A means that we take the letter that is after the word from and we draw a north. Here it's already drawn for you, but it's important to be able to realize where to draw the north. And then we move clockwise until we reach the point or the line that joins these two letters. So we want to reach the line AB. And this bearing here, this angle here is 105. It's important to realize that we're always moving in the clockwise direction. Now, we want the bearing of A from B. Again, we start by drawing a north at the letter that is after the word from. So at B, we draw the north. Again, here it's already drawn for you. And we move in the clockwise direction until we find the line AB. So we are looking to find this angle theta. How would we be able to find this angle theta? First of all, we need to find the angle X. And since X and the 105 are co-interior angles, we can say that 105 plus X equals 180. So X is equal to 75. So this is angle X here because of co-interior angles, because the north is parallel to the north. So the two angles are co-interior. So instead of the X here, we now have 75. And theta is simply 360 minus 75. And this gives us 285. So the bearing is 285 degrees. And this is the correct answer. The bearing of X from Y is 274. Calculate the bearing of Y from X. So we have a point X and a point Y somewhere here. It doesn't really matter where you draw Y. The important thing is to follow the same procedure. The bearing of X from Y. So I need to draw a north at Y first. So Y is here. And the bearing is 274. So we move in the clockwise direction until we reach the line XY. And this angle here is 274. We are required to calculate the bearing of Y from X. So we need to find the north at X first. So this is the north. And we move clockwise until we reach the line XY. So this is the required angle, angle theta. So first we find angle X here, which is 360 minus 274. This gives us 6. This is 5. This is 2. 15 minus 7 is 8. So the angle X here is 86. And then we do 180 minus 86. And that gives us 94. So the angle theta is equal to 94 because, again, they are co-interior angles and they are supplementary. So their sum is 180. Hence, we do 180 minus 86. So the correct and final answer is 94. And this is correct according to the marking scheme. You might be wondering about the 0 that they wrote at the beginning. It's traditional to write bearings as 3 digits like this. But if you don't write the 0, it doesn't really matter. The answer is still correct. So let's move on. We will now move to more complicated questions. The diagram shows the positions of 3 points A, B, C in a field. Show that BC is 118.1, correct to 1 decimal place. So BC is letter C or whatever, opposite to the angle, and we're going to use the cosine rule, of course. So C squared is equal to 80 squared plus 115 squared minus 2 multiplied by 80 multiplied by 115 multiplied by cosine 72 a lot of people make mistakes because they don't include brackets like this here. So you must include these brackets in the calculator so that the calculator understands the expression correctly. And then we do 80 squared plus 115 squared minus, open brackets, 2 times 80 times 115 times cosine 72. The answer we get is c squared equals 13939.08, but that doesn't really matter. Then we get the square root of the answer. So on the calculator, c is equal to the square root of 13939. And this is equal to 118.06. So to one decimal place, c is equal to 118.1. And we correctly solved A and we showed what they required. Next, we want to calculate angle ABC. So let's put theta at angle B here. And we know that this is 118.1, as they told us in question A. We want to find theta, so we use the sine rule. We have opposites here and we have opposites here. So we simply write 118.1 over sine 72 equals 115 over sine theta. And we cross multiply. So 115 sine 72 equals 118.1 sine theta. And then we divide by 118.1. We can cross this out from here. So we evaluate the fraction on the left. 115 sine 72 divided by 118.1. We get 0.926 whatever. And we do shift sign of the answer. So theta is equal to 67.83, or just 67.8 to 3 significant figures. Let's check the marking scheme. 67.8 is correct. Next, we are told the bearing of, so let's first write 67.8 so as not to forget. So this angle here is 67.8. And the third side is 118.1. So this is the information that we have so far. The bearing of C from A is 147. Find the bearing of A from B and the bearing of B from C. So the bearing of C from A, means that I draw the north at A, and that's already drawn here. And I move clockwise until I reach the line AC. And the value of this bearing here is 147. So this angle in total is 147. I can get 147 minus 72. So this gives me 5, this gives me 7. And that tells me that the angle here is 75. Automatically. Next, we want the bearing of A from B. So to get the bearing of A from B, you need to draw a north at the letter that follows the word from. So we have here from B. So we draw the north at B. And we want to move clockwise until we reach AB, not BC, because here the two letters we're dealing with are A and B. So the line we want is the line AB. So we're looking at this angle here. This angle is easy to get, similar to what we did in the last problem. So we first get this angle X here. Angle X is 180 minus 75. And this gives us 105. So we write 105 at this point here, this angle. And then we do 360 minus 105. And that gives us 255. So the angle here would be 255. Next, we are required to get the bearing of B from C. So the bearing of B from C, we follow the same protocol. We draw a north at point C. So let me draw the north right now. So the north would be somewhere here, for example. And we want to get the bearing of B from C. So we need to move clockwise until we reach segment BC. So to get the angle, we are looking at this angle here. So this very small angle, let's call it, for example, angle theta. We are trying to get this very small angle here. How do you think we can get it? So first of all, we think to ourselves, this angle here is 147. So this angle is 180 minus 147. And this subtraction would give us 33. So the angle here is 33. Now, can we get angle C as a whole? Yes, we can. So angle C would basically be 180 minus the sum of the other two angles in the triangle, which are 72 and 67.8. So let's use the calculator to quickly evaluate this. First of all, 72 plus 67.8 gives us 139.8. So angle C is approximately 40.2. Next, we want to get theta. So theta would be 40.2 minus this angle here, 33. And that gives us 7.2 degrees. So the first answer of CI, as we said, is 255. And the second answer is 7.2 degrees. 255 degrees and 7.2 degrees. Let's check the marking scheme. Thankfully, they are correct, 255 and 7.2. So moving on, the diagram shows a field ABCD. The bearing of B from A is 140. C is due east of B and D is due north of C. Find the bearing of D from B. So in order to find the bearing of D from B, we have to go to B and we have to draw a north. So there is the north. And then we need to join the line BD like this. And we need to get this angle here. We move clockwise from the north to the line. So the bearing of D from B would be this angle theta written in blue. How can we get that? Similar to the logic that we applied in the last problem, first we begin by getting this angle over here. This angle is simply 40 because it's 180 minus 140 owing to co-interior angles. So this angle here would be 40. Now, if we can get angle B in the triangle, so if we have like triangle ABD like this, and we can get angle B here, let's call this X, for example. This would help us a lot because if we subtract 40 from this angle X, we get the theta that we're looking for. So what information do we have about A and B and D? First of all, AB is equal to 400. And we can also get BD using the Pythagorean theorem. So let's draw triangle BCD. BC is 350. CD is 450. So we can simply compute the Pythagorean theorem as 350 squared plus 450 squared. So 350 squared plus 450 squared. This gives us 570.08. So we can just write 570. That would be sufficient. Now that we have BD equals 570, we want to figure out a way to get side AD. So how can we do that? How can we get side AD? So let's just call this point here point M. I'm just going to erase the north for now. I'm going to replace it with this line here. It's also a north in a sense, but it stops here at this point, M, and we still want this angle theta here. So how can I get side AD? I can start by figuring out what this length is. And how can we do that? First of all, this here is 90. So the remaining part here would be 50. How did I get the 50? I did 140 minus 90. And that gave me 50. So in triangle AMB, we have an angle of 50. And we have a hypotenuse of 400. And we want to get X here. So all we have to do is just cosine 50 equals X over 400. So X equals 400 cosine 50. And X equals 400 cosine 50 is 257.115. So 257.1. So this part here is 257.1. And we can also get this side here as well. We can use either the sine rule, or we can use Pythagorean theorem. They should give you both the same answer. So let's do the Pythagorean theorem. Since we have 257.1, we can use the Pythagorean theorem to say root 400 squared minus 257.1 squared. And this should give us the value of BM. So root 400 squared minus 257.1 squared gives us 306.4. So 306.4 would be the side MB. And then we can also get this side here. Now that we know that this part is 306.4, you can subtract 450 minus 306.4. This gives us 143.6. So looking at triangle AXD, let's put point X here. Looking at triangle AXD, we can figure out that AX is basically composed of two parts. AX is composed of this part here, which is 350, plus this number that we got, which is 257.1. So if we add 350 to 257.1, we get 607.1, and this is the value of AX. Now we can get the distance AD. So XD is equal to 143.6. And we can just do the Pythagorean of both. 607.1 squared plus 143.6 squared. So 607.1 squared plus 143.6 squared. And then we take the radical of this answer. We get 623.9 for AD, or 624. So by the way, this solves B. And sometimes in math, you can follow a certain path and you can find yourself getting the answer to B before A. That works. There is no problem. There might be an alternative way where you can get A first, but this also works. So now we have 624, which is the distance from D to A. And we're going to use that and the cosine rule in order to find our angle X. So we're just going to put 624 here. And we're going to do the cosine rule to get angle X. So cosine angle X is equal to 400 squared plus 570 squared minus 624 squared over 2 times 400 times 570. I'm going to evaluate the numerator. 400 squared plus 570 squared minus 624 squared. This is 95524. And the denominator is 2 multiplied by 400 multiplied by 570, which is 456,000. So cosine X equals 95524 divided by 456,000. And we just do shift cosine to get the answer. And the answer is 77.9. So angle ABD is 77.9. And if you remember, we were trying to get theta initially. So theta is equal to angle ABD as a whole. Let me use a different color. So this angle here in yellow is ABD, and ABD is 77.9. And on the other hand, we were told, or we obtained this angle here, this small angle here, as 40. Let me rewrite this, 40 here. So in order to get the remaining part, you do 77.9 minus 40. So this angle theta is equal to 77.9 minus 40. And you get 37.9. So let's first check if our answers are correct. We have 37.9 for the first part and 624 for the second, and they are correct, thankfully. Let me just rewind and take you on a very quick summary of what we did, because this was a bit messy. So I want you to figure out the steps that we took in order to find what we want. So first of all, we drew a north at B. And we called this point here M. We are required to find the bearing of D from B. So we joined BD like this. We said that we want this value of theta here. In order to get this value of theta, we needed two quantities. First of all, this quantity here, which is 40. And we used co-interior angles to obtain the 40. Our next step was to draw triangle ABD and to try to figure out the big angle, angle B, which we did. We got this big angle here, and then we did angle B minus 40 equals theta. In order to find angle B, our method involved finding AD, which is another requirement in the question. So we found AD, and then we found angle B, from which we obtained theta. There might be other techniques, but that's not our issue right now. How did we get angle B? So we were given AB equals 400. We used the Pythagorean theorem to get this side here. And then we used a lot of other triangles to get the third side. So in order to get AD, we looked at this triangle here. And you were trying to get the two sides of the triangle. Let's call this point, for example, point N. We had to figure out ND, and we had to figure out this long side here, AN. So AN is basically consisting of two parts, MN, which is 350, we already know that, So we were required to find this side AM here, and we used this triangle to do that. After getting AM, we also got BM, and then we were able to get this side by just doing 450 minus BM. This is the main logic of the question. Having obtained all the sides, we were able to get AD, which is colored in green, and then we applied the cosine rule to get angle B. So moving on, we are given here a triangular field ABC on horizontal ground. In question B, we are required to use the cosine rule to find angle BAC. So angle BAC is this angle here, theta. So remember that the opposite will be the 180. This is going to be our C. Cosine theta is equal to 150 squared plus 120 squared minus 180 squared divided by 2 multiplied by 150 multiplied by 120. So using the calculator, you have 4,500 in the numerator divided by 36,000 in the denominator. And you want to find theta, so you do shift cosine. Which is 82.8 degrees. Let's check the marking scheme. Yes, the correct answer is 82.8 degrees. Now let's write that down. So angle BAC would be 82.8. Next, we're required to find the bearing of B from A and the bearing of A from B, given that the bearing of C from A is 210. So the bearing of C from A, that means that we draw the north at A, which they've already done for us. And then we move clockwise in order to reach line AC. AC, which is the line that brings together these 2 points. So we are given that this bearing here is 210. Immediately we can do 210 minus 82.8. And that gives us the remaining part of the angle, which is the exterior part here in blue. So this blue part here is given as 127.2. And we can write it down because it might help us in the future. Now we want the bearing of B from A. So nicely enough, this is actually the answer to CI. This is 127.2, and let me show you why. Again, it's from A, so we draw a north at A, but this time we are rotating clockwise until we reach AB. So let's do that on the drawing. Here is the north. And if we rotate clockwise until AB, this is the angle we're looking for. So this is 127.2. It automatically fits. Now we want the bearing of A from B, so we need to draw a north at B. And again, we need to move clockwise until we reach the line AB. So we want this whole angle here. Not until BC, but until AB. Watch out, because you might make the mistake of moving clockwise until you reach only BC. This would be a mistake. You have to continue all the way until you reach AB, because the two letters involved in this question are A and B. So again, we're rotating until we reach line AB. So how would we get that? This is pretty simple. We first get this angle X by doing 180 minus 127.2. And we get 52.8. And then we do 360 minus 52.8. And we get 307.2. So the bearing is 307.2. Let's check the marking scheme to make sure we are on track. So 127.2 and 307.2 are the correct answers. Finally, we are told D is a point on AC that is nearest to B. Calculate the distance from D to A. So, excuse me. Let me just retrieve we're only going to need the angle value here, just this angle here. So it's 82.8. We can remove everything else. The bearings aren't really important for this last part. So 82.8. We want the point on AC that is nearest to B. So nearest means we have to draw a perpendicular line. The nearest point to B has to be the perpendicular point. We are required to find the distance from D to A. So we are required to get the distance dA, let's call this X, and we know that this angle is 90 as well. So how would we be able to do that? This is very simple trigonometry. We have triangle BDA. We want this distance here. This angle is 90. We already know that this angle is 82.8. And we know that the side AB is 120. So side AB here would be the hypotenuse. This would be the adjacent. So we can use the cosine rule. Cosine 82.8 is equal to adjacent, which is X, over hypotenuse, which is 120. We can cross multiply. We get 120 cosine 82.8 equals X. So 120 cosine 82.8. That gives us 15.03. So we can just approximate and we say X equals to 15. Let's check the marking scheme. Thankfully, this is the correct answer here, which brings us to the end of our video. I hope this has been beneficial. Thank you for watching.